Hey, this is for Algebra 3. We're ACT Prep. It's quiz 1.4.3 is due Friday, April 17th. Now, this quiz mostly concerns vocabulary, dealing with probability distributions. There's a little bit of vocabulary here. There's a discrete variable that it's going to be talking about and a continuous variable that it's going to be talking about. A discrete variable can only be certain values. So let me explain what that means. The grades on your report card, you could have an A, a B, C, D, or an F, or E, whatever they put on there. But those are the only values those grades can be. They can't, you might have an A plus or A minus, B plus, B minus, something like that. But you have a small number of values. You can count them. The sides of a coin. You have the heads and then you have the tails. So there are two sides of the coin. There are no other sides of the coin. So they can only be certain values. A continuous variable can be any value. So, for example, any real number between 0 and 1. So an example of a real number between 0 and 1 could be 0.1, or it could be 0.4756238. So you can see there's a lot of numbers between 0 and 1, and it can be any of those values. It doesn't have to be a set number of them, it can be any of them. So that's the difference between discrete variable and a continuous variable. A discrete has a set number of possible outcomes. A continuous variable does not have a set number of possible outcomes. So another just little bit with discrete and continuous probability. A discrete probability distribution, if these are the probabilities of certain events occurring, that is a probability distribution. They must add to equal 1. So if you add all these fractions together, they will equal 1. Now, if the individual fractions, if they add together and they don't equal 1, say they equal 5 over 6, that is not a probability distribution. It must equal 1 if you add them all together. It's discrete because there is a certain number of them. In this, there's only 4 possibilities. So they have what's called a countable number of elements. In this case, there are 4 of them. You can count that there's 4 elements in there. And none of these probabilities can be negative. You can't have a negative probability. So that's like saying I have a negative 20% chance of doing something. So there's no such thing as negative probability. And probabilities are always between 0 and 1. Another example of a discrete probability distribution is if you look at a single dice. It has the numbers 1 through 6 on the die, and you have a 1 out of 6 chance of getting each number. So the individual probability of rolling a 3 is 1 out of 6. Same thing for rolling a 4, it's 1 out of 6. So you can assign a 1 out of 6 probability to 6 different occurrences. So you can have a 1, 2, 3, 4, 5, or 6, and they each have a 1 out of 6 probability. So that's another example of a discrete probability distribution. A continuous probability distribution is a little harder to understand because you haven't really dealt with it yet. But it has what's called an uncountable number of elements. So let's look at that example again between 0 and 1, the real numbers between 0 and 1. There's no way to count the real numbers between 0 and 1. So the probability of picking a number between 0 and 1, that's like a continuous random variable. It can be any number between 0 and 1. Again, just like the discrete probability, they cannot be negative. And it's usually, the continuous case is usually represented by a graph or an equation because that's the only way you can display a continuous case. And when they give you a graph, the area underneath the graph is 1. So if they give you a graph that looks something like this, say it might come up here, might have a hump in it. It may even have 2 humps or something, or maybe that goes on forever. You don't know. The area underneath this graph must equal 1. So you have to use calculus to determine that area, unless they give you a way to determine the area in the problem. There are some problems where you are able to determine the area using like geometry. But you have to use calculus in order to really get the area under that curve. So don't worry about that so much. All you have to worry about is that the area under that curve and over the x-axis is 1. And that's what makes a continuous probability distribution. But really, guys, that's about it for ACT Prep today. It's all the questions are concerning this information and just recognizing the difference of these two probability distributions. If you have any questions, please let me know and I'll be happy to answer them.